1 on page 19, and what is written? It is written that limit x approaches a, xn minus an by x minus a is equal to nan minus 1, means limit of this function at a is n times a power n minus 1, where he says where n is an integer, and what a is a positive number. So now we solve it, and we have case 1. As we know the set of integer, this is set of integer 0 plus minus 1 plus minus 2 plus minus 3. He says whatever n you substitute from this set, we have of n. One is positive n, one is 0, the other value is negative. So there are 3 possible values of n. So we discussed case 1 when n is positive integer. Suppose n is positive integer. We suppose n is a positive integer. When n is a positive integer, then how we evaluate this limit? And the first step, we just substitute. So what we see on substituting, x is equal to a, we find 0 by 0 form, which has to be avoided. We have to transform it into a form which is not indeterminate. Now if we substitute as x approaches a, we have to substitute x equal to a. When we substitute x equal to a, we find 0 by 0 form. 0 by 0 form is indeterminate form, which has to be avoided. So now what we do for this, we factorize. That is, what do we mean by factorization here? We factorize xn minus a power n. How can we factorize? Students, we will try to understand it from examples. N is an integer. We know that xn minus an can be of the form x minus a. When we substitute n equal to 1, we form x minus a, which is 1 multiplied by x minus a. It is factorized. If we write value of n 2, it becomes x square minus a square. It will become x minus a, x minus a, the other factor is x plus a. Everyone knows this. And if we substitute 3 in it, it becomes x cube minus a cube, and this will be equal to x minus a times x square plus ax plus a square. So with power 1, with power 2, with power 3, we can see that this is the factor x minus a, x minus a, x minus a is factor. So by proceeding like this, if we generalize, xn minus an will also have a factor x minus a, and with it we will have a factor. You know that if power is 3 and x minus a is 1 factor, then the other factor has 1 less degree than given. Given as cube, this has 2 degree, 1 less than that. It is x square minus a square. If we separate x minus a from it, the other has 1 degree, 1 less than this. It has 2, it has 1, it has 3. By separating x minus a, we have the other factor of the lesser degree. Its degree is 3, its degree is 2. Now we can proceed with the same pattern. This factor will have one less degree and one less, it has n degree, then the degree is xn minus 1, one less here. Degree will be one less here, and what is it? N minus 1. Here a power has 0, a has 0 power, a has 0 power, here x has 0 power. Every time we write ax, 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 ax or xa, 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 so on, xa. What happens here? X power decreases from 2, 1, 0. Power of x decreases from 2 to 0. Power of x decreases from n minus 1, n minus 2, n minus 3, so on to 0. Power of a increases from 0 to 2, 1 less than this. This has 3 power. Power of a increases from 0, 1, 2. 0, 1, 2, so on up to 1 less than this. This is n, it will be n minus 1. This is how it is factorized. Xn minus an will be factorized as xn minus an. Its one factor is x minus a, the other factor is xn minus 1 plus xn minus 2a, xn minus 3a square, so on. And in the end it will be, the degree of x will be 0 and the degree of a will be 1 less than this. This is n, this is degree of a. 1 less than that is an minus 1. We factorize this form, numerator xn minus an. Xn minus an is factorized as this. If you are going to multiply these two factors, x minus a with this, you will definitely get xn minus an. The product of these two is xn minus an. Now what we do, we had to evaluate this limit. We write it. X approaches a, xn minus an by x minus a. Now in the next step, x approaches a. We write this factorized. What is its factorized form? X minus a, xn minus 1, xn minus 2a, xn minus 3a square, so on, an minus 1 divided by, we write this numerator factorized and denominator unchanged. Numerator factorized and denominator unchanged, it is x minus a. This is cancelled with it, and now x approaches a, it means x will be replaced by a. We can do it. A power n minus 1, a power n minus 2, a power n minus 3, x is now replaced by a as x approaches a here. Limit is applied, a square, so on. It is a power n minus 1. So if we can see keenly, everywhere it is n minus 1. The two powers are added, a power n minus 1, a power n minus 1, so on, a power n minus 1. Right. After that, what is it? A power n minus 1, a power n minus 1. It were written twice, then we would have written 2an minus 1. If it had been written 3 times, we would have written 3 times an minus 1, but it is written n times. So we write n times an minus 1. How many times this term is written? N times, so we write an minus 1. This is its answer, students. We have evaluated this limit, and the answer of this limit is an minus 1, the same as he says here. This was case 1, and now we will move to case 2. Case 1 is, suppose n is positive integer. Case 2 will be when n is negative integer. We will have to suppose its value n is negative minus m, we suppose this, where m is now involved, m is positive integer. We can write this n belongs to this set. पॉजिटिव इंटीजर सेट के एलिमेंट के साथ माइनस साइन लगा दिए, मींस, या फिर हम इसको ये कह सकते हैं दैट माइनस एम बिलोंग्स टू नेगेटिव इंटीजर सेट, ये भी कह सकते हैं माइनस एम बिलोंग्स टू दिस सेट. माइनस एम इज द वैल्यू ऑफ एन, वेयर वी कैन राइट इन दिस वे, वेयर एन इज इक्वल टू माइनस एम, and this time belongs to negative integer set, so it is negative integer, right? We have to keep m positive because positive m will have negative sign, so then it will be negative integer. Now students, again we have to evaluate the limit. Under this condition we have to evaluate limit. Look at it, this limit is to be evaluated. Limit x approaches a, xn minus an by x minus a. Now this time we said that n is equal to minus m, means it is negative integer, so this will be replaced. X approaches a, xn it is written, now we write it minus m, a power n, n is minus m this time, divided by x minus a. What can we write it next? We can write it as x by 1. If I write 1 by xm, then the power will be positive. It is a by 1. If I write 1 by a, power will be positive, divided by x minus a. Then we do this, limit x approaches a, we take LCM. Already in the denominator it is x minus a, LCM is x m a m. This will appear here am, minus this will appear here x m. If we take minus sign common, that will appear here x approaches a. By taking minus sign common, xm will be positive, written first, am will be negative, written later, divided by this value. Second value appears with third, xm am along with x minus a in the denominator. These two will join each other, will be together. Now students, we will see the next form. Next we separate this and separate the structure xm minus am by x minus a. So we can write it in this form, limit x approaches a. This is in the second location in the denominator. Can be written as, to show it in the denominator we can write 1 by xm am. Also we write limit can be splitted. You know that when functions are multiple in product, limit can be separated to both of them, so we separate this limit. The other part is xm minus am by x minus a. Now we evaluate this limit. X approaches a means we have to replace x by a, 1 by a power m, a power m. Here it was x, now it is a. Now answer of this limit is, we found in the case 1, we found in case 1 what is answer of this limit. xn minus an by x minus a had answered n a n minus 1, we proved in part in case 1. So the same form is with m power, so answer will be m a m minus 1. The reference is by case 1. It is by case 1. The answer of this limit is m a m minus 1. Now what we have, we can write minus m, numerator value. A is written at the 3 places, we write a here, m minus 1. It is written numerator from denominator, both m will rise in numerator and will be with negative sign, minus m minus n. These two powers will be subtracted from numerator a, minus m a power, these two are cancelled. What is a power? minus m minus 1, but we write here minus m is equal to n. In this case we kept minus m the value of n, so minus m can be replaced by n. And what is on left hand side we have? On left hand side we have, this can be written in the form, finalized form, with left hand limit x approaches a, xn minus a n by x minus a takes this form now, is equal to, this is equal to this right hand side, and right hand side is minus m a power minus m minus 1. But we write, what we write? Minus m is equal to n. Then answer of this limit x approaches a, xn minus a n by x minus a is minus m is n, a power minus m is n minus 1. This is answer. So in both cases we can see, students, that when we keep the value of n negative, when it is negative integer, then n is minus m. By keeping that also and evaluating, we can see easily that answer is n minus 1. So when n is positive integer or negative integer, answer of this limit is n minus 1. n is 0 if we substitute the value of n 0. Then this structure reduces to this form, x minus a, limit x approaches a. Then it will be 1 minus 1 by x minus a, limit also continues with it. We can write it in next step, x approaches a, it will be 1 minus 1 0, 0 by x minus a, limit x approaches a 0, answer will be 0. So for two kind of values of integer, one positive, the other negative, this is the answer. When n becomes 0, this structure becomes 0, this structure becomes 0. So left hand side, right hand side, both 0. 0 also satisfies left hand side, right hand side. 0 can make them equal. This will be 0 we evaluated, and this will also be 0 when n is 0. Can be seen n is in product, and when it becomes 0, then right hand side will also be 0. So this can be proved by substituting this just in left hand side and right hand side value of n 0. So for third kind of value of integer, it is also valid. For two values, one positive, one negative, the other positive, the answer is n minus 1. This limit equal to this. For n equal to 0, both of them are equal. If this is separately evaluated and this separately, both give 0 left hand side, right hand side equal for 0 also. So n can have, when n is integer, it can have three possible values. This negative, and the negative value case, answer is n minus 1. In positive value case, in case 1, the answer was n minus 1. Right? This limit as answer n minus 1 in both positive and negative integer case. When we substitute 0 in it, both left hand side and right hand side become 0 when evaluated separately. So 0 also satisfies both of them. And students, this was the proof of the theorem. You can turn over the page and see page 20. Hence we write the conclusion, and what the conclusion is. Hence, in both cases, limit x approaches a, xn minus a n by x minus a, the answer of this limit is n a n minus 1. This is answer, conclusion.